So first of all, we have a 3-point linkage here, category 2. One important point at the linkage is here a pendulum crate sitting here to avoid the tether that it's swiveling behind the tractor when you run it in the field. So we break it here. Of course, we have a turning point here in this axle going to here, that when you drive around the curve, the tether can move, but with the brake we avoid the machine jumping to the side. When we look to the driveline, we just have a simple PTO coming from the tractor. We have a maximum PTO speed of 540, and then we go directly into the center gearbox here, sitting here, to split the power to the left and right side. Then we go from rotor to rotor with a hexagonal shaft. It's sitting inside here in the main frame, and we need to interrupt the hexagonal shaft at each folding point of the tether, where we need to fold into transport position. So when you look underneath here, there are cardan joints from Walderscheid. They are maintenance free, so you don't need to grease them to reduce here the maintenance effort and the maintenance costs for the farm. The frame is a thick wall square frame here for a long lifetime. It's really robust. The rotors itself, we have here the rotor blade, the rotor head above. It's greased inside, so there is no oil filling. That means there is no risk of a leakage, there is no risk of a contamination of the crop with oil. It's relatively simple. You have 2 greasing points here. One is in the back above and one is underneath to grease the axle towards the wheel underneath. The rotor tines are made out of flat spring steel. That's can differentiate from competitor to competitor. There are 2 types. First is flat spring steel, like here. Some others are using a tube as a tine arm. The disadvantage of a tube is that the contact area between the tube and the plate for fixation is really small. With a flat spring steel you have much higher contact area. It's easier to mount the tine arm. When you are using tubes, you often need a counter plate from underneath to get the tube fixed here on the rotor blade. Another advantage of the flat spring steel is that it's flexible. So when you have obstacles in the field, it can move up and down a little bit. With the tube, it's not possible. Furthermore, the twin tines are mounted underneath the tine arm. When you look often to tube tine arms, they are going through the winding. And then that means you have not so much space for the tine going backwards, because it's limited in between the windings by the tube. And another thing is we have here anti-loss protection. So when one tine is broken, it will be kept here by the anti-loss protection. For the tines, we are using twin tines. We call them supersede tines, and they have the same length here. We are not using right and left hand tines like others do. So that means for you as a dealer and also for the customer, they only need to stock one sort of tine, one part number, that's it. What's the idea behind the equal length tines? We see that here when we are in working position. So this rotor here is in working position. The rotor itself is a little bit swiveled to the front, and then both tines have different heights. The first tine in front is picking up the top layer of the crop, and the second tine is picking up the lower layer of the crop. So you have a better mixing effect afterwards to spread the material behind the tether. Another thing to adjust here is the angle of the machine, so the spreading angle. We have here at each wheel 3 positions, 3 possibilities to adjust the spreading angle. Now it's in middle position, it's the compromise for farmers, so they often use middle position and never change the spreading angle, so that's often what we see. But we have here 15, 18 and 21 degrees of spreading or of adjusting the spreading angle. Do you know why it's needed to adjust the spreading angle, or what's the advantage? Yeah, better throwing. So we need to differentiate between the first time of tedding after mowing, then the grass is laying on little windrows behind the mower. Then we can go with a steeper cutting angle, tedding angle for better spreading. When you go the second or third time for doing hay, for example, then the material is already spread, and you can go to a more flat angle to pick up easily or more easily the crop in front. With a flatter spreading angle, it's easier to pick up the crop in front. So that's the reason why you can adjust it. Furthermore, when you go the first time after the mower, you should run at maximum PDO speed, so 540, to be more aggressive to the crop, to fasten the drying process and to have a better spreading quality behind the tedder. For the second or third run with the tedder, you should reduce the PDO speed, because you have a mechanical impact of the tines towards the crop. When the crop is getting more and more dry, you are creating crop losses due to the mechanical impact. So you should reduce the PDO speed to also reduce the mechanical impact towards the crop. Another thing is, what would you say, what's the best forward speed for the first run behind the mower with such a tedder? It's slower, yeah, compared to the TDX. So my recommendation is 5 to 6 kilometers per hour. The reason for that is, when you drive too fast, 8, 9, 10 kilometers per hour, the portion of crop per twin tine is higher. And then the spreading quality is not so good anymore. So the slower you operate, the better is the quality of spreading after or behind the tedder. Another thing to adjust is the tire pressure inside the rotor wheels. So you will often find some stickers here beside the wheel, 2.0 bars here, but it's the maximum pressure of the tires. My recommendation, reduce it to 1.2, 1.3 bars. It's enough. It's not a heavy weight. On these rotors. The complete machine has 880 kilograms, so you can easily run it with a low horsepower tractor, 60, 70 horsepower. And when you reduce the pressure inside the tires to 1.2, 1.3 bars, it doesn't start jumping in the field. So it's running much more smoothly over the ground. So please check that, especially when you make the pre-delivery inspection of the machine, or when you are just in front of the season after winter to get the machine ready. Another thing we have here is, actually just run the machine with a single acting valve. So no big requirements for the tractor. 3-point linkage calibrated, single acting hydraulic valve here, and then we have the PDO here for running the rotor. We need a single acting valve here for folding up the tedder. We have here 2 hydraulic cylinders. They are connected to each other, and then you can lift the rotors. We have here now the headland position, so the outer rotors on both sides are lifted a little bit. When you lift now the lower linkage, they are touching the ground or the soil here at the outer side. So that's the reason for this headland position, we call it. When you pull this red rope and activate or operate the hydraulic valve, you will fold up the machine into into transport position. Then you are at 250, something like that, width for going on the road. But it is only one issue: bring the machine into transport position. At the beginning, I mentioned that at each folding point here, we have cardan joints in between, and they need to be in position to make it possible to fold the machine. Otherwise, they will be damaged. That's the reason why we have here a mechanical disconnection by this gray this grey metal sheet is connected directly to the folding unit. So when we fold up the header, we disconnect the gearbox inside. And then the hexagonal shaft and also the cardan joints can turn free and can be brought into position automatically. So we can't destroy the cardan joints inside. That means you can run the tether at 540 and start folding up. It's noisy, of course. We disconnect here, but you will not damage the driveline of the machine. When you fold it out, we automatically engage the gearbox in the middle, and you don't do nothing as an operator. It's relatively easy to run the machine. At the border of a field. So when there is a fence, when there is a ditch, when there is a neighbor field, and then we run like this, so straight in a 90-degree angle to the tractor, we spread also the material above the border. Then we have the possibility to use an edge spreading. So we can turn the complete machine to one side, to both sides. That's the reason why we have here another rope, the black one, to pull. Lower the machine like this, pull the rope, bring the steering wheel, the steering column of the tractor to one side, then you drive slowly forward, and then you move the machine into the edge spreading position. I will show you that in a few seconds, and then you can run the machine at the border of the field. So I will do that now. We can do that to both sides. So we have here 3 holes. The middle position is just the working position, and then we have 1 hole for the left and 1 for the right side for the edge spreading. For the working quality of such a machine, we have 2 important things. First of all is the rotor diameter. The smaller the rotor diameter, the better is the working, the spreading quality behind the tether. And another important factor is the overlap between 2 rotors next to each other. So the overlap here of both tine arms, the higher the overlap, the better is the spreading quality of the machine. So there is sometimes, for example, a 7-meter tether with 6 or 8-meter tedders with 6 or 8 rotors, and I always would choose the 8-rotor machine to have a smaller diameter of the rotor for better spreading quality.
How does the diameter affect the spreading?
Sorry?
Having a smaller diameter, how does that affect it compared to a large one, the speed?
No, not really. Maybe a little bit, it's faster, yeah.
But just to get that overlap.
Yeah. Exactly. For the ground following, it's really important to have a short distance in front between the rotor wheel and the tine in front. So the closer the distance, the better is the ground following of the machine. The general ground following is done here by the tractor. So the rear axle is following the ground, and with the lower linkage we adapt it towards the ground. We run the machine always in floating position. So for the hydraulic here, for the folding, we go to floating position, and also for the lower linkage, we go to floating position. So the machine can move and follow the ground. For better ground following, when you have really hilly conditions, there is an option available for this machine. It's a gauge wheel, which we mount directly here at the 3-point linkage, and then you run also the machine in floating here of the linkage, but you do not you do the height adjustment with different holes here, so you can lift and lower the gauge wheel to adjust the height of the working height of the tines. Without the gauge wheel, you just do it with the top linker here of the tractor. When you make it longer, you increase the working height. When you make it shorter here, you decrease the working height. The edge spreading device here mechanically with the rope is standard. so you don't have to leave the cap. You just pull this rope and then you drive forward, turn it to one side, and then you can bring it into edge spreading. There is another option available that you don't need to pull the rope anymore. You have an hydraulic cylinder inside, and then you need another double acting valve to do this process here hydraulically out of the cap.